Welcome to all my dear student. In last session we discussed about electrolyte replacement therapy. Example for inorganic substance used for electrolyte replacement therapy. Sodium chloride and potassium chloride and calcium gluconate. So that and all we already discussed in the previous session. So this class will discuss about potassium chloride. So what is the molecular formula for potassium chloride? KCl, and what is the molecular weight? 74.55, and it is a in nature it is found as potassium chloride or carnallite. Potassium chloride, it's a mixture of, that means contaminated, mainly it is mainly contaminated with magnesium sulfate and chloride. It is silane and carnallite, that means potassium chloride, magnesium chloride and 6 molecule of water. So it is mainly contaminated with magnesium sulfate and chloride. Then how can we prepare potassium chloride? When it is treated with potassium carbonate acidified with hydrochloric acid, so the formation of potassium chloride and H2CO3. So then next, what is the properties? We'll see. Color, it is a colorless cubical crystalline powder. Odor, odorless. Taste, saline taste. Solubility, soluble in water and glycerol, insoluble in alcohol and solvent ether. That uses we already known about. It is the source of ions and also potassium deficiency and treatment of myasthenia gravis and nothing but muscle weakness and antidote in digitalis intoxication. So these are the uses of potassium chloride. Next we'll see about calcium gluconate. So calcium gluconate is somehow we already studied in hematonic. There we studied about ferrous gluconate. The similarity between the preparation of calcium gluconate and ferrous gluconate. They are preparing from glucose, then glucose on oxidation, gluconic acid, thereby after it is treating with here calcium carbonate, so that the calcium gluconate is formed. There we are treating with, instead of here calcium gluconate, there and for ferrous gluconate will treat with barium sulfate, so that barium gluconate, there after that it is to be separated from ferrous, treated with ferrous salt, then it is to be treated with ferrous gluconate. But here that first, what is the calcium gluconate formula? So C12 H22O14 CaH2O calcium gluconate, or otherwise you may write this formulation also, COOCHOH 4 times and CH2OH overall twice calcium H2O. So these are the two types of writing formula. This either you may write this type or this type. Okay, it is not less than 99% and not more than 103% of calcium gluconate. And preparation, it is first treated with glucose in presence of bromine or sodium bromide or dilute nitric acid, then it is converted into gluconic acid. Then after that gluconic acid preparation, then it is treated with calcium carbonate, calcium gluconate, and thereby removal of carbon dioxide. This calcium gluconate is crystallized from the filtrate. Okay, so this is the main method of preparation of calcium gluconate. Once again let me repeat the same. So first, how do you prepare calcium gluconate from glucose? First, the glucose, what is the formula for glucose? C6H12O6. And when we are treating with oxidizing or on oxidation or with treating with bromine water and dilute nitric acid, thereby one oxidation to be added here, so that what is the molecular formula for gluconic acid? C6 H12O7, but glucose C6H12O6 by oxidation or an oxidizing agent. Here O6, instead of O6 we are going to add one more oxygen, so it is converted. This is glucose formula, this is the gluconic acid. So thereafter we are going to treat with the calcium carbonate. So here the calcium carbon dioxide released and calcium salt go and adjoin with that gluconic acid, so it is converting into calcium gluconate, the same gluconic acid. After that, overall it is to be twice into calcium and water molecule. So this is the formula for calcium gluconate. It is very easy once you understand the concept of formula for gluconic acid and calcium gluconate. Okay, then it is to be crystallized from the filtrate. Next we will see about the properties. It is a white crystalline granules or powder. White crystalline granules or powder. Odor, odorless. Taste, tasteless. And characteristic, it is stable in air, but it loses its crystallization with decomposition at 100 degree Celsius. Solubility, soluble in water, insoluble in chloroform, ether and alcohol. So these are the, it's very easy to remembrance also. Okay. Next we'll see about, and also incompatible with the oxidizing agent or solution of calcium gluconate get precipitated by oxalate or borate, etc. That means if calcium gluconate and oxidizing with the any oxidizing agent oxidized with, so it is converted into borate or oxalate. Okay, on adding hydrochloric acid or other acid to the solution, gluconic acid is said to be formed, which gets converted easily to gluconolactone. So this is already we are doing from the beginning. First glucose to be converted into gluconic acid. The same if glucose, what is the characteristic of calcium gluconate? First and adding hydrochloric acid or other acid to the solution, the gluconic acid is found, said to be formed, which gets converted easily to D-gluconolactone. It is converted into D-gluconolactone. We'll see about calcium gluconate and acidification. Here gluconic acid and removal of calcium chloride. Next, this gluconic acid on hydrolysis converting into D-gluconolactone. So only changes here. There are CH2OS, CHOH 4 times. So here the CH and make a form with the lactone ring with the C double bond O with lactone. So it is known as D-gluconolactone. Okay. Next, identification test. Aqueous solution, that means the substance to be dissolved in water is nothing but aqueous solution, and adding with ferric chloride, yellow color or precipitate is found out. Next, it forms phenylhydrazine. So it is decomposed, and adding with phenylhydrazine, it is decomposed at 200 to 202 degrees Celsius. So these are the main identification, two identification for the calcium gluconate. Next we'll see test for purity. First one, acidity and alkalinity, completeness of the solution, arsenic, lead, chloride, sulfate and dextrose and sucrose is the main important test for purity here. The same we are following from ferrous gluconate also. Why? Because that gluconic acid is formed that will react with the calcium gluconate. And one more thing, incompatibility. So first we'll see one by one. So first, completeness of the solution, how to perform the test for purity. 2 gram of the substance dissolved in boiled and cold water. In a conical flask, you have to take 2 gram of the substance dissolved in 100 ml of boiled and cold water. Maintain at a temperature 20 to 20 degrees Celsius for 6 hours. Occasional shaking. The solution should be less from any crystalline powder. It means not clear, that means cannot be said to conform to IP standard. So the solution become not clear. The solution should be clear from, so the solution become not clear from any crystalline powder. So next we'll see about dextrose and sucrose. Because of presence of gluconic acid, here we know that gluconic acid, how we are preparing when glucose on oxidation to form the gluconic acid. So this gluconic acid, that means the presence of this gluconic acid can be tested by using Fehling solution after hydrolyzing sucrose with boiling dilute hydrochloric acid. It is very important test for purity here. Next one, assay. It can be analyzed or assayed by complexometric titration. There and ferrous gluconate also assayed or analyzed by the same complexometric titration. Then how do you perform the complexometric titration? There are two types of method of analyzing from with the calcium gluconate. BP method in 1980 editions. So low solubility in water, dissolved by adding in sufficient water, neutralizing with sodium hydroxide. That pH adjustment treated with disodium meditate using calcium carboxylic acid as an calcan carboxylic acid as an indicator. It is nothing but first the aqueous solution neutralized with the sodium hydroxide, then it is titrated with ethylene EDTA, ethylene diamine tetracetic acid. Next, using calcan carboxylic acid mixture as an indicator. Third, IP method. By using this IP method, the titration involving replacement with magnesium using 5 ml of standard magnesium sulfate. So titration is involving requirement replacement with magnesium and using 5 ml of standard magnesium sulfate. Here the pH is adjusted with ammonium chloride buffer. The volume of disodium erytate equivalent to magnesium sulfate solution is subtracted from total disodium erytate and used, and then results are calculated. So each ml of remainder of 0.05 m disodium erytate is equivalent to 0.00242 gram of calcium gluconate. So how do you prepare by IP method? So it is nothing but same as that of BP method. So here we may only thing there we will neutralize with that. In BP method we will neutralize with the sodium hydroxide. Here we are going to, instead of sodium hydroxide, the pH is adjusted with ammonium chloride buffer. Then it is titrated with disodium. Then it is titrated with disodium erytate using calcan mixture as an indicator. So what is the use of calcium? It is used as a calcium deficiency or hypocalcemic tetany, and dosage here 2 to 10 gram to be given orally or parenterally, and IV or IM to be given 1 to 2 gram of calcium gluconate. It is a sources of iron. Thank you.